So, one of the lessons for today is talking about interpreting constants of proportionality. And so this goes back to what we talked about a little bit last week about proportional relationships. And proportional relationships can be determined basically by taking your K, which is your proportional relationship, or R if you're talking about Khan Academy proportional, but they're both basically the same thing. You take your Y value divided by your X. Your Y value is usually the dependent, and the X value is usually your independent. Or another way of looking at it is your output divided by your input. So, when we look at proportionality, we're always looking at what value depends on the other to find that value. So, when we talk like about miles per hour, the miles is your output, the hours are your input, which makes this the independent, and this your dependent. And so when we talk about constant proportionality, we want to see if it has the same output divided by input ratio for all the values that are possible. And so we're going to look at a couple examples. So here we have an example. If the average family uses 20 kilowatts of power per day, how much power, P, would the family use over time, T? This equation is represented by P equals 20T. So when we look at this equation here, this is your output, this is your input. So we're going to put in time to figure out how much power we use over time, which is the output. Now, this is also your independent, T is your independent, and P would be your dependent variable. How much power you use is dependent upon how much time has passed. And so what we have here then is we have to decide then, what does the 20 really mean? Well, the 20 is how much kilowatts. It's a constant. So every day that passes, you use 20 kilowatts of power. So time, because of that, is based on the time that we have right here, which is days. So how much power would be consumed over 15 days? Well, we look at our equation, P equals 20T. The little star there, of course, means that you multiply. And so the 15 days, is that power or is that time? That's the first question you have to ask yourself. And that will tell you where the 15 goes into this equation. Does it go into the variable P or does it go into the variable T? So take 15 seconds to see if you can decide which one it's going to be. Hopefully you said it was T. So all you have to do then is go P, because we don't know what P is yet. And you go 20 times 15. And if you multiply that together, of course, we would get 300 kilowatts. So after 15 days, we have 300 kilowatts. So another thing we have to look at then is how long would it take to use 5 kilowatts of power? Well, to do that then, we have 5. Oh, let me back up here. We're going to have power equals 20T again. Except if we have 5 kilowatts of power, this time it's going to go into the P. So we have 5 equals 20T. And then to get T all by itself, since we are multiplying right here, we have to do the opposite, which means we have to divide both sides. So we divide both sides. The 20s go to 1T. And then you have this fraction, 5 over 20. And if you reduce it, you get a nice, neat fraction of 1/4. And since we're talking about time, we don't want hours, we want 1/4 days, because our time is in days. So one of the other questions that may come up is also, what does this 20 mean? Well, you always have to go back and look at the base problem a lot of times. And so the 20 means, of course, 20 kilowatts of power per day. So you always have to try and figure out what that number in front of the variable means. That number is usually the coefficient, is a constant of value of something. And so what changes over time? And so in this case, it's the 20 kilowatts of power changes over time. So building on what we just talked about, here's another example. We can calculate the distance traveled by a car based on the speed of the car and the amount of time traveled by the equation D equals RT. So D is distance, R is the rate of miles per hour, your speed, and T is, of course, time. In this case, since our rate is based on hours, our time should also be based on hours. And so if you have an equation D equals 50T, what we have to figure out then is, what does that 50 really mean? And so in this case, if we look at our original equation, D equals RT, the 50 has been substituted for R. So that means we're talking about rate of miles per hour. So the R equals 50 miles per hour. So when you have these type of equations, you have to work your way backwards from the original, figure out what did you plug in. In this case, we plugged into the variable R, and that R was the rate per miles per hour, so your 50 then is miles per hour. Now, how far would you have traveled after 5 hours? Well, we write down our equation, D equals 50T, and since this is hours, is it going to go into D or T? Well, hours is time, so it's going to go into this T here, and so that will then give us D equals 50 times 5, which of course will give you 250 what? In this case, you always have to remember your variables since we're dealing with our not variables, but our units, and so it's 250 miles. Now, how long would it take to travel 10 miles? Well, this time we know our distance. So 10 equals 50T. This is multiplying, so of course that means you need to do the opposite, which is, I'll give you 3 seconds, 2, 1. Now you should be able to say that it is division. So the opposite of multiplication is division, so that means we have to divide both sides by the number in front of the variable we're trying to solve, which in this case is t, so we divide 50 divided by 50. 50 divided by 50 is 1t, and then we divide this side by 50, and then of course you can reduce it, and so that would take you 1 hour, or 1/5 of an hour. So it would take you 1/5 of an hour to travel 10 miles, and if you multiply that by 60, you'd find out that it would take you about 12 minutes. Right. So now, how can we read a table for proportionality? Well, to read a table for proportionality, you always want to refer to this table as an data table. And a data table is usually broken into 2 columns. Usually the first column is your independent, second column is your dependent, X and Y. And so you want to look for the 1 on the X column if there is one. If there is, great. You know that for 1 hour worked, you're going to earn $15. The other way to look at that is $15 is 1 hour of your time. So when you're working a job for $15 an hour, you're saying you value your time for $15. You're willing to give up 1 hour of your life to work for them for $15. Now, if your skills are not high end skills, then you're not going to get paid that much. The more skills and the more specialty you know, the more you get paid. But, so, what does this one mean? That means you work 1 hour and you get paid $15. What does $120 mean? Well, that means you're earning $120 for this amount of hours of your life, or 8 hours of work. Or for 8 hours, you get paid $120. So sometimes you're going to have questions based on the table, how much do you get paid an hour, or what does this number mean? And so that's what they're looking at. So one last example. So here's one that doesn't have a 1 in it. So first we have to find out what is the unit rate, or what is our proportionality statement. So once again, this is X and this is Y. So when we talk about proportional statements, you want to do Y over X, which means for every 3 seconds, we complete 5 setups. So what that means then is, if we're talking about the 5 is 5 sit-ups in 3 seconds. So what would the 18 mean? The 18 means is it takes you 18 seconds to do 30 sit-ups. And so if we were also to look at constant proportionality here, do each of these give us a 3 seconds to 5 sit-up ratio? Well, the only way you could do that is actually divide each one. 3 over 5, check. What about 12 over 20? Well, 12 over 20 can be divided by 4, which gives you, once again, 3 over 5. So that also has a 3/5 ratio. Let's do 18 over 30. Is this also an 18 over 5 ratio? Well, they're both divisible by 6, and so that would give you 3 over 5. Check. And so 45 in 27. 27 over 45, both divisible by 9, and that would give you 3 over 5. So once again, check. So this is constant, 3/5 all the way around, and you just have to interpret what do those numbers mean. So next up is how do you interpret proportional graphs, and so that's what we'll be looking at next.